In this video, we will learn about phase changes of matter. I'm sure you know the phase changes of matter, solid, liquid, and gas, and what happens when it goes from one phase to the other. For example, we have a solid here, and as I increase the temperature, if I heat it, the solid will, here is a liquid, okay, so solid will melt, all right? And this melting of solid, I have to provide the heat. So this is endothermic, it is absorbing heat. Okay, so this is endothermic process where solid goes into liquid. If I keep heating it, all right, it will go through evaporation or vaporization. That turns it into gas. So that is also endothermic. Now if I keep heating, if I take the gas and or let's go this way, that if I heat the solid, there is a possibility that I can convert the solid straight into gas, and that's called sublimation. This is also endothermic. So sublimation is endothermic, okay, the melting is endothermic, and the vaporization is endothermic because it is taking heat. Now on the other hand, if I take the liquid and I take the energy out of the liquid, I am freezing it, cooling it. Okay, I have to cool it to freeze, and when I'm cooling it, that is exothermic, energy is going out. All right, same thing, if I cool it further, I can convert, not cooling it, I can cool the gas to convert it into straight solid. So that is also exothermic. If I take the gas and cool it, the particles are moving at very high speed. So if I cool the temperature, the kinetic energy goes down, so they settle down. Once they settle down, they start holding each other and they convert it into a liquid. Okay, and that process is called condensation. So that is also exothermic. So we must understand what is endothermic, what is exothermic here. So as I'm telling you, we have melting, which takes in heat, vaporization takes in heat, okay, and sublimation. All these three are endothermic, and opposite to this is exothermic. So we need to understand the phase changes. If we understand the phase changes, endothermic phase changes and exothermic phase changes, the next topic we want to talk about is the phase diagram. So we need to understand this chart right here. This is called phase diagram. It represents three different phases of matter. It has to go this way. It can be labeled by whichever alphabets. We must understand that it will go from solid to liquid to gas. So if it's going from solid to liquid, then this is melting. Melting is happening on this line. Anywhere on the line, this is the temperature. So anywhere on the line is the melting point. In this liquid to solid would be freezing. Okay, liquid to gas, right, is vaporization, and then gas to liquid is condensation. And here you see that the solid converts straight into gas below this point. So if I take this point out, if I'm below this point, the pressure is lower. This is pressure. So if I lower the pressure and I lower the temperature, I can convert solid straight into gas, which is sublimation. So it shows all three states of matter, and it shows all the 6 changes of the matter. Okay, so when I'm talking about all 6 changes of the matter, I must understand which one is endothermic, which is exothermic. All 3 phase changes depend on the temperature and pressure. So these are the 2 main variables. So if I increase the temperature, I know that it will go from melting to vaporization. If I decrease the temperature, I know I'm going backwards, so it will go from gas to liquid, which is condensation, and then liquid to solid, which is freezing. But at the same time, I can lower the pressure. Okay, so lower the pressure can also do the same thing. So lowering the pressure will also condense the same liquid, okay, same gas into the liquid. So if we need to see how can we read the temperature and the pressure to make these changes. Now here there is a point that's right here. Okay, that point is connecting the 3 phases of matter, and this point is called triple point. Okay, so the triple point is the temperature. This is the temperature. At this temperature and at this pressure, all 3 phases of matter coexist. All 3 phases of matter coexist. That is triple point. Okay, a point at which all 3 phases of matter coexist. That means at this temperature and at this pressure, I have melting, freezing, vaporization, condensation, sublimation, deposition going on all at the same time, all at equilibrium. So all three phases of matter are at equilibrium. It is not a condition that we can attain in the classroom, but yes, it is possible in certain circumstances. I have to create the environment, and if I do create the environment, I can possibly attain this situation where all three phases of matter exist in equilibrium. And here is the point, okay, that's called critical point. Critical point means it is a point, it is the temperature and the pressure beyond which there is no distinguish between solid, liquid and gas. Means I cannot liquefy the gas anymore. They kind of blend together. So that is called critical point. Okay, so I'm going to redraw this graph for you. So I have temperature on the x-axis and I have pressure on the y-axis. So I go it like this. Okay, it always has to go solid, liquid, and gas. So you must understand that anywhere on this point is going to be the melting point, because this is between solid and liquid, melting point or the freezing point. As I increase the pressure or decrease the pressure, the melting point, or the freezing point will change because of the change in the pressure. Okay, so and anywhere on this line is going to be the boiling point or the condensation point. So we must understand these factors. All right, and then this thing here is called the triple point. Okay, this is called triple point, where that means that at this temperature and at this pressure, all three phases of matter, solid, liquid, and gas, coexist or exist in equilibrium. This is called critical point. Okay, that beyond this temperature and pressure, I cannot liquefy the gas. So this is called phase diagram. You need to understand the phase diagram. Here is the labeled phase diagram. I suggest that you go ahead and label it. We have temperature in Celsius and pressure in atmosphere, and I'm going to pause it right here. So here is the triple point, here is the critical point. You understand this is vaporization, condensation, melting, freezing, sublimation, deposition, and all that. So it has to go solid, liquid, and gas. So this is all about phase diagram. These are different vocabularies we are going to use for phase diagram. So solid going into liquid, so we understand this is endothermic. Okay, and then liquid going into gas is also endothermic. Okay, gas into liquid is exothermic, and liquid into solid is also exothermic. It loses heat and it gains heat. It tells you right here as well. And this is this phase diagram. So the vocabulary for the phase diagram, you must understand the definition of triple point, the temperature and pressure at which all three phases coexist. You must memorize the definition of the critical point, normal freezing point, and normal boiling point. This is the temperature and the pressure. This is the temperature at the standard pressure, 1 atm. Like if this is, let me erase it. If this is, we are using the unit of atm, the atmospheric pressure, we know that 1 atm is the standard pressure. So at standard pressure, whatever the point is, that is going to be the normal melting point or normal boiling point. Like for this particular liquid, it doesn't melt or boil at normal condition. It can only sublimate. But let's say your pressure was right here. So if the pressure is right here, then this is going to be the normal melting point, and this is going to be the normal boiling point. Okay, so keep that in mind. That at standard pressure, this is the standard pressure, 1.0 atm. Okay, so if this is how the graph looked like for the standard pressure, 1.0 atm, then this was going to be the normal melting point right here. Okay, at standard pressure, and this is going to be the normal boiling point. Okay, so that's all about phase diagram. We must understand this, take notes, and I suggest that you always read the pages that are in the book. That gives you a clear picture of how things work, and we will do these questions in the class. All right, everybody, thank you.